Welcome to Debugging 101 in Online GDB. My name is Tiffany and I'm a PhD candidate at UCF as well as a member of the XRT lab. So let's get started. A common email that I get as a TA is, "Help, I'm segfaulting and I don't know why." So let's try using a debugger to help us figure out why we are segfaulting. So I opened up Online GDB in this window. Online GDB is a free IDE that includes a debugger, so it can be pretty useful to you. So here I've written a small program. What this program does is that it takes in an input file, it reads in the first number in it, and then adds together the numbers up to n, and also gives us back 2 times that number. So it just adds together 0 plus 1 plus 2 plus 3, and 0 plus 1 plus 4 plus 8, and then prints out this number, the total and the 2 times total. But if I run this program, I can see that I got a segmentation fault core dumped. So this isn't really helpful to me. So let's click this debug button to help us figure out why we're segfaulting. If I click debug in this top right next to this run, I can then click start right here. And then it will highlight the line that I'm segfaulting on. So I know that I'm segfaulting on line 10. And the debugger should give me some message here about why I'm segfaulting. It says, no such file or directory. So I'm segfaulting at line 10 because I have no such file or directory. So line 10 is reading from in.txt, but I get this message, no such file or directory. So that means I didn't include in.txt into my program. So let's go ahead and do that. I should make in.txt and give it a value. So now when I run this program, what I get is the correct total, but this is clearly not 2 times the total. My 2 times total is not 1 billion if my n is 6. So clearly something is wrong. So we need to continue debugging and figure out what is wrong. We can do that using breakpoints. Breakpoints are a point that you can stop the program right before that line. So I can add a breakpoint on any line, and my program will stop right before the line executes and show me all the variables that are currently in the program. In a breakpoint, I can do multiple things. I can do step into, step out, step over, and continue. Step into will step into the function, including any C functions. Step out will step out of the function that I'm currently in. So if I stepped into a function and I want to get out of it, I can use step out. Step over will move the debugger to the next line. While continue will move the debugger to the next breakpoint. The difference between step over and continue is that this just goes to the next line regardless of what it is, and this will skip all the lines until it hits the next breakpoint. So let's go ahead and try to use some of these in some examples. So let's say that I know for a fact that my 2 times total is wrong. I don't know why. So 2 times total, 2 total is only being changed in line 16. So let's go ahead and put a breakpoint there. So now if I click debug, my program will run right until line 16. It will stop right before 16 runs. So if I click debug and then start, it will run all the way until right before 16. So important thing to note is that a breakpoint will stop right before this line executes. So line 16 hasn't yet executed. On the right, I can see all my variables. So currently I is 1 because I starts at 1, and then my n is 6, and my total is 1 because I added 0 plus 1 already. But my 2 total is negative 4,912. So that is clearly not right. So right when my for loop starts, my 2 total is incorrect. So I know for a fact where my issue is. If I click step over, I will just go to the next line in the program. Since I'm in a for loop, it should take me back to the first for loop. If I click step over, it will take me back to the beginning of the for loop. Click it again, it goes to the next line. Now you can see I has changed. N is still 6 because we haven't executed 15 yet. And my 2 total is now 4,911. I click step over again. You can see that total has changed and 2 total has not changed yet because I haven't executed yet. I click step over again. Then you can see 2 total has changed. And I can just keep going through every line. Now let's say I'm sick of my for loop and I don't want to keep going through my for loop line by line. What I could do is that I can remove this breakpoint and I can add another breakpoint right here. And if I click continue, the program will run until it hits this breakpoint. So now I go on to this breakpoint and I can see all of my stuff after the for loop executed. So after the for loop executed, my n is 6, and that's correct. My total is 21, and my 2 total is negative 4,891, which is clearly not right. If I click continue again, then I should get to the end of my program, because continue should take you to the next breakpoint or the end of your program. So now my program has exited normally because I got to return 0. So now I know my problem is that when I started my for loop, my total is incorrect. And that's because I never instantiated total to 0. So the memory just gave it some random value, like negative 4,000. So if I instantiate this to 0, remember you need to stop your debugging before you edit your code, it will tell you that. If I instantiate this to 0, and I run again, it should say my total is 21. And that's because I didn't do 2 times I here. So now it should say 42. So let's look at another example. So here I have another program. It's pretty much the same thing, except this time what I did is that I called my add_n into a separate function. So I didn't put it in main. I put it in a separate function and I assigned total to it. So if I run this program, and let's say I didn't make my total equal to 0, you can see the very same issue that I had last time, where my total is some random number from the memory. So what I could do here is I could add a breakpoint when I call this add_n. And I could run debug, and it'll start from the main and we'll go to that first debug point. And what I could do is I could click step into. So step into will actually take me into this function that I called. If I click step into, I can go inside the function that I called. And when I click step over, what it will do is it will take me to the next line in the program. So here I can see that my total is a very large number before I even start my for loop. So that is my issue here. I keep clicking step over, the next line, and that just keeps doing the for loop. So let's say I'm sick of this function and I want to get out of it. I can just click step out to come back to my main where I called step in. So I can click step out here and it'll bring me back to my main. And I can click step over to go to the next line or continue to go to the next breakpoint. So if I click step over, bring to the next line, step over one more time, and then I'm done with my program and it reached return 0. So that is a quick overview of step into. So let's look at another example of what we can use a debugger for. So here I have another simple program. I have a structure called SomeObject, and all it has is an x and a y variable. And then I made an array of this object. So I have an array of 4 objects. And then I filled this array for every single object up to 4, and I gave it the x and the y. And I just set the x and the y to I and I plus 1 respectively. So some interesting things that I can do actually is that I can put a breakpoint right here, for example, right before I assign something to x. If I click start, I can see the actual array values. So I can see that all of my array values are garbage right now because I haven't really assigned them yet. Because remember, the breakpoint will stop right before this line executes. So if I click step over, you can see that my x will change to 0. And that is what I want. So I can also just click, I can also watch an expression as well. So let's look at some other things too. Print will print out the variable that you ask it to at the breakpoint. And this is a terminal command. You can also keep a watch on specific variables if you want to keep them in like their special zone. So here, display variables, I can enter expression to watch. So let's say I want to keep a watch on array I.x. And then it'll just tell me the value of array I.x every time I click something. So now array I.x is 4,100 something. And then I click continue, it should assign this array I to the x. So now array I.x is 1. So here I can keep a watch on certain types of variables. I can also see that right here. But let's say that your array is very big. It's like 2,000 things long and you can't keep track of all the arrays in the local variables. What you can do is that you can actually use a terminal to keep track of some stuff. So let's say at this line specifically, I want to know what array I.x is. I can type print array I.x and then they'll just literally print the variable for me. And array I.x is equal to 1. I can also do that for y. And y should be some random value yet because we haven't yet executed it. If I click step over, I can actually print array 1.x. I can give it the exact index even, and we'll just print out that exact thing at array 1. Array 1.y. It will print out the exact thing at array 1.y. So these are some useful things I can do. And if I want to just go to the very end of my program, I know all of my array values. So my first structure says 0, 1, 1, 2, 2, 3, 3, 4. But I can also print them here. So I want to print the second structure as x. I can print array1.x, and that'll give me 1. I can also do print array1.y, and that will give me 2. So this can be really helpful if you have a lot of things in an array and you want to get the certain one at a certain breakpoint. So these are all I have for debugging basics, and hopefully this can help you in some of your projects and assignments.